So we're coming into a more complex equation. We were asked to graph the function tan of a half times x minus pi on 4 equals y between the domain of x is minus 2 pi and x is equal to 2 pi. So the first thing that I always like to do is to rewrite my tan function in the general form. So y equals a tan bx plus c plus d. So that means I'm going to expand the inside of my bracket, and I'm also just going to write a 1 out the front because our a is 1. And then tan, b would be x on 2 over half x, plus, a half times minus pi on 4 would be minus pi on 8. And our d is really just 0 in this situation. This way I can see the elements of the graph that I want to sketch. So if a equals 1, this means it's not reaching infinity any faster or slower. There's no stretch or compression as such. If d equals 0 at the end, there's no vertical shift. And b equals a half, that relates to my period. So the period is pi on b, so pi and a half, which equals 2 pi. That means it takes the length of 2 pi's to start again the graph. Now I've got to find out where the graph starts. So I can do that by finding c over b minus pi on 8 over a half. That equals negative pi on 4. Now notice that's also seen in the non-expanded version, but when you have the expanded version, always find c over b, and that will tell you the shift. So it's opposite to the sign that we have. So minus pi over 4 means we horizontally shift to the right. There's no vertical shift, so that can tell me the starting point is going to be pi on 4 for my horizontal axis and then 0 for my vertical axis. So pi on 4, 0. And it's going to cross through the x-axis. It will pass through that, every plus 2 pi onto that, and every minus 2 pi from there. Lastly, I just want to find the asymptotes. So we recall that tan is really sine over cos. So I just take the cos of whatever is inside my expanded bracket. So cos of x over 2 minus pi on 8, and I let that equal 0. Because remember, sine over cos, that's tan. Tan has an asymptote when cos is 0. So I know cos is 0. The first time I know cos is 0 is at pi on 2, or 90 degrees. So I let x over 2 minus pi on 8, let that equal pi on 2. Rearrange for x, so plus on the pi on 8 times by 2. And then I know there's an asymptote at 5 pi on 4. And again, this is going to occur when we plus on the period 2 pi, or we subtract the period 2 pi, and we keep going in that pattern. Now I have everything I need to sketch this beautiful tan graph. I'm going to start with where it crosses the x-axis. So I know it will cross it at pi on 4. I also know it will cross it if I plus on 2 pi from this point. So that would be 9 pi on 4. And I'm going to leave the domain for a little bit. I'm also going to then say, well, it's going to cross the x-axis if I subtract 2 pi. So that's negative 7 pi on 4. So let's put those points in. And then we can also put the asymptotes in as well. Here's my domain. So minus 2 pi is a little bit to the left, and 2 pi is a little bit before that last point where my graph hits the x-axis. First asymptote, well, I've got that. It's halfway between pi on 4 and 9 pi on 4, and we've written it down. That's 5 pi on 4. So be very clear where your asymptotes are. I'm doing this in purple, and then we'll have another one. Remember 5 pi on 4, if I minus 2 pi, that will give me the other asymptote here. So I get minus 3 pi on 4. Beautiful. Everything else stays the same. So it's not reflected. So we go from bottom to top around the pi on 4. And again, we start from negative infinity towards that 9 pi on 4. But I'm going to stop just before I get there at 2 pi. So it's going to stop just below the x-axis. And the same to the other side. Notice how I stop at minus 2 pi. That's my graph between minus 2 pi and 2 pi. Now I'm going to solve this graph for the tan half x minus pi on 4 equals negative 1. So what you can do is you can do a little bit of an estimate here. Where is y equals negative 1 on this graph? And then draw a little dotted line where you think that could be. I think it's going to be just below where my graph finishes at negative 2 pi and 2 pi. And then I can see how many solutions I think I should get when I solve algebraically. I see it crosses twice, so I'm probably going to get 2 solutions. So let's find those 2 solutions. We're going to solve the function. Remember, it's within the restricted domain. For x is within minus 2 pi to 2 pi. First step. Normally we would move any numbers surrounding or outside the tan function to the right-hand side. In this case, my a was 1, so I don't really need to move anything across. So that step is already done for us. The second thing is I'm going to have a think and solve one solution that I know that tan theta equals negative 1. And then I'm going to solve that for x. So I always like to put my unit circle up and just make sure I have one solution for tan theta equals minus 1. Can you think of it? I know tan is negative in, say, the second quadrant. You can choose another quadrant if you like. It doesn't really matter. And I know tan is equal to 1 or negative 1 when I have a triangle like this. On my unit set, hypotenuse is 1, and that angle in the triangle is pi on 4. So to get to that point, I need to go 3 pi on 4 units around my unit circle. That is one solution for tan theta equals minus 1 when theta is 3 pi on 4. But remember, I don't have a theta. I have half x minus pi on 8. So I'm going to solve that. Let it equal 3 pi on 4. And then move everything across until you have x by itself plus the pi on 8 times by 2. And I think it's about 7 pi all over 4. And that's just one solution of my equation. And notice it lands within the domain minus 2 pi and 2 pi. So I think that's okay. The third thing we do is know that my graph is going to hit minus 1, 7 pi on 4, plus its period or minus its period. So I can write the general solution being x is actually 7 pi on 4 plus 2 pi k. where k is just an integer, or plus my period. Okay, so let's look if we add on just one period here. So if k is 1, I would have x equals 7 pi on 4 plus 2 pi. And I'll check, is this in the domain and is it a solution? Because I'm plussing on 2 pi and I already have 7 pi on 4, that's going to take me way outside. So that can't be a solution. If I just left it at k equals 0, well, that would just be x is 7 pi on 4, and we know that's a solution. I can always try to minus a period as well. So this is when I have k is -1. So x would be equal to 7 pi on 4 minus 2 pi. Okay, and that will give me, I think, minus pi on 4. Now this is good because minus pi on 4 is between minus 2 pi and 2 pi. If I try to subtract another period, right, so I let my k equals -2 this time, I'm going to end up with something, again, too small or outside that -2 pi range. So, like we thought, we have two solutions, x equals 7 pi on 4 and minus pi on 4. Again, go and see your graph and see if those solutions are similar to where you thought they would be. 14b. So this is a really important part for Year 12 Spec. So take your time, get to know it, and really ask for help whenever you need it.